Is Asemahle Mboya. Thank you for your question. I like your question, and the same as what I said to Miyelani, some of those questions are repeats. So I'm going to deal with the new issues in the question. Okay, let's just analyze the given information. Here we have a root of multiplicity 2, and we have a 0 in front. So immediately we know that this graph is going to come up, cut through x, and then turn at 3 and go back up. There's nothing difficult about seeing that from the equation that they gave us. Then they also said the derivative at the point 1 and the derivative at the point 3 is equal to 0. So at 1 here we have a turning point, and at 3 we have a turning point because the gradient is 0. And then they are cheeky enough to sneak that in. They say the coordinates of that point is 1 and 4. And I think it's part 3 of your question. Let me just see. Yeah, the second part says, sketch the graph, indicating all the points with the axes, etc., etc. The first part of your question says, show that f has a point of inflection. Excuse me. So your point of inflection, remember, x equals minus b over 3a, or where your second derivative is 0. So we're not going to look at those. I want to go straight into question 8.4 here. This is a beaut. They say the following. Determine the coordinates of the local maximum turning point of h, or stationary point of h, if h of x is obtained by taking f of x minus 2 plus 3. Okay, and it's a 2-mark question, so it should not take you a lot, shouldn't take a lot of work to answer this particular question. Let's see, how do we interpret it as a transformation? Now remember, in your transformations, if this is x minus 2, it means you move to the right 2 units. And the point in question here is the local maximum of this curve h, which is this point over here. Now I'm going to put the point down here, and I'm going to leave spaces so we can interpret what happens. Here we have a vertical translation upwards of 3 units. Now how does this translate into the coordinate pair? If I move to the right, in the brackets it says x minus 2, but on the graph I need to add 2. So I go to my point 1 and I add 2 to x, and here the same thing. For the x's, sort of the opposite is what happens. For the y value, you do exactly what it tells you to do. So for h, the local maximum turning point would lie at the point 3 and 7. Now that is really a very nice question in an exam. It asks you to interpret the information that happens in a transformation. How does that information change what we're looking at in terms of the graph and its coordinates that we have? Don't forget that in the x you do the opposite. If it said x plus 2 there, I would have gone to the graph and I would have subtracted 2 from all the coordinate pairs, because that means the graph has to move to the left. If it says x minus 2, the graph moves to the right. If it says plus 3, and that plus 3 is far away from the x, you plus 3, it's upwards. If you minus 3, it's downwards. Okay, so know your transformations, Asemahle, and what they do to your graphs. Let's see whose question I can look at now. I'm going to look at, let's pause with the graphs a bit, and let us go to Rebaona's question on derivatives. Now remember, last week we worked with the power rule of the derivative, and the power rule said the following. F of x, if f of x is given as ax to the power of n, okay, then if I want to find the derivative of that, the power comes down, It multiplies with the existing coefficient, and the x has the old power minus 1. That is what we refer to as the power rule for derivatives. Now, what I like about the question that we have is that Rebaona has sent us 3 questions that really tests and pushes the boundaries. They work with rational powers. They work with a rational power over a fraction. We'll talk about that in a second. Okay, so let's look at the first one. The first one asks us to find d. Now remember, I addressed this notation last week with you guys when we looked at the calculus, the derivatives. So it says differentiate whatever's inside here with respect to x. Another way to say this is to just say capital D x in front of the bracket. Okay, but they gave us d dx. The two things mean the same thing. Okay, the first question is x cubed. Sure, plus 1 over 2x cubed multiplied by the root of x. Now, folks, I'm sure you will agree with me that does not even come close to the power rule, the way it's written there. So we have to do some mathematics here. We have to go and multiply those things out, use our exponential knowledge, add powers, subtract powers to get it into this form that we need it in. Okay, so we're going to go through this one very slowly. First of all, let's change everything to powers here. Folks, now I want you to notice this thing over here is very, very, very dangerous. It is 2x cubed. The 2 has got nothing to do with the x cubed. So that's catch number 1. Catch number 2 is the x with a root over it, because that ushers in an ugly fraction of a half in the power. So work slowly. Let's see how we can do this. This stays x to the power of 3. This is multiplied then by the root of x, which is x to the power of a half, plus. Now, folks, this is not 2x to the minus 3. If you do that, you fell into the trap. The 2 remains in the denominator. Only the x goes back to the numerator with a negative power. Okay, so please don't do this. You are going to fall into the trap that this question has set for you. So we leave the half where it is, and this becomes x to the minus 3 multiplied by x to the power of a half. We are still not ready to differentiate, because we can't differentiate that product. We can only do that if we do AP maths or if we are at university one day. So at high school, you have to multiply and get it ready to look exactly like the power rule. So we're still not differentiating, we're ddxing still. Here we get x, 3 plus a half is 3.5, which you don't need your calculator for, please. This is elementary grade 2 mathematics. Make sure that you know how to add those fractions quickly. You don't want to waste time on your calculator. Plus a half, and then here we have minus 3 plus a half. Leaves me with x to the minus 2.5, which is minus 5 over 2. Now it's the power rule. Can you see we had to go through a little bit of extensive mathematics before we could differentiate. Now we differentiate, so now we're going to drop the dx. This becomes 7 over 2, x to the power 7 over 2 minus 1. Now I'm going to summarize it minus 2 over 2 because we know that is what 1 is. We're subtracting fractions, so we need an LCD. It's as simple as that. The next fraction will be plus the half. The power comes down as minus 5 over 2. X is minus 5 over 2. And here's the next catch, minus 2 over 2. You're not going to add 1 there. That's a classic misconception or a classic simple mistake that we make. when we work with powers that are negative that we're differentiating. Okay, so all that's left for us is to clean this up quite nicely. We have 7 over 2, x to the power 7 over 2 minus 2 over 2 is x to the power 5 over 2 minus 5 over 4, top times top, bottom times bottom, x to the power minus 7 over 2. Now, folks, usually, that is where your differentiation stops, unless the examiner says, leave your answer with positive powers. Then all that happens is that x to the minus 7 over 2 over here will return to the denominator from whence it came. It will be minus 5 over 4x to the 7 over 2. It's pretty much neither here nor there. But if they do say, leave it with positive powers, then that is what you have to do. Okay, so that's the first question. We had to do some work. It caused us to enter into the domain of rational powers before we could differentiate. Let's look at the second question over here. The second question says find ds dt. Now, to find ds dt, somewhere you must have an expression s in terms of t. That would then be the same as dy dt. So it says take the expression in s and differentiate it with respect to t. So this is what we're looking for. Okay, and they gave that to us. They indeed said that s, let me just get my eraser here, get rid of that, that s is equal to, wow, 3 times the square root of t to the power 5. Rebauna, this is nasty. Nasty questions, but we can't just do questions that are easy here, because this can pop up in a paper. Don't think that you can't get this on a paper, a question paper, folks, because it looks so funny. It can happen. Okay, so if we look at the question and we look closely, we see at the top of the fraction we have 2 terms, and at the bottom we have 1 term. So we're going to split the fraction up. 3 times the square root of t to the 5 over 3 times the square root of t to the power 5, and that I'm going to immediately say is 1, plus 2 times, and this is a little bit of work that we have to do. So it's 2 times t to the power 3 over 2. Remember, your exponential law says the following. The th root of b to the power c is b to the power c over a. And that's the rule that I'm applying in this step. Okay? And that's going to be over 3 times t to the 5 over 3. So I've got a little bit more work to do there before I can continue with the derivative. This one dissolved quite nicely. Okay, I'm just going to make a little bit of space here for us to write. So here we end up with 1 plus, now remember what I said, the 3 stays put. The 3 has got nothing to do with that variable t. So it remains 2 over 3. It doesn't become 2 times 3. In other words, the 3 doesn't go up with the t, folks. Please make a note of that. That is the classic mistake that you guys make when you're under pressure in an exam. Okay, so this becomes 2 over 3, t to the 3 over 2 minus 5 over 3. And that is ugly. The denominators are different. So 1 plus 2 over 3. T, the LCD of the two denominators is 6. This will be 9 minus 10. And I can finally differentiate 1 plus 2 over 3. T to the minus 1 over 6. This is still S. I'm still panel beating the problem so that it looks like the power rule. Okay, so now I'm ready to differentiate. Now I can say, from now, ds dt is equal to the derivative of this constant is 0. The 2 over 3 stays put. The power comes down from the t. The old power subtracts with a new power, which I know is minus 1. So in my head, I'm going to say 6 over 6. And that gives me 2 over what is this? The 2, let's simplify this rather. The 2 goes into the 6 3 times, so that will leave me with a beautiful coefficient of minus 1 over 9. T to the minus 7 over 6. And as I said, if the examiner says leave it with positive powers, the t goes back into the denominator. Okay, so this answer is finally minus 1 over 9t to the 7 over 6. This is the derivative of s with respect to t. Okay, now folks, that is mainly our program for today. I just want to talk about the last derivative that Rebaona gave us. Rebaona, this derivative that you gave me says the following. Find dx of the cube root of x to the minus 1 plus 2 over x cubed plus 2x to the 4. We've got a little bit of problems here. If we look at what we've got here, this is a function that looks like this, and it has a power over it, okay, which creates huge problems for us. We can only do this one day when we're at university. So that question will not be asked in a matric paper. In an AP Maths paper, definitely. So if you do AP Maths, folks, you can expect a question like this. You clean it up, you make the powers positive, you collect all your x's, collect the power over the function, and apply, AP students only, the chain rule. Okay, so Rebaona, thank you for that. I really appreciate the brilliant questions that you guys gave us. Please get those questions coming for, I think next week we might maybe look at word problems and application problems for the calculus paper.